Hi, my name is Anthony Moa, and my study group partner is Jonathan Garcia. We're group 14. Today we'll cover some temperature conversions, metric to metric, sig fig rules, and solve some equations. For temperature conversions, we had to remember some things. Kelvin is equal to Celsius plus 273. Celsius is equal to 5 divided by 9 times Fahrenheit minus 32. And Fahrenheit is equal to 9 divided by 5 times Celsius plus 32. For example, we're going to convert 72 degrees Fahrenheit to Celsius. And in order to do this, we need to follow the Celsius rule. So for this question, we do 5 divided by 9 times 72 minus 32, and we get 22 degrees Celsius. This equation is converting 2,500 degrees Fahrenheit to Kelvin. In order to do this, we map it out, Fahrenheit to Celsius to Kelvin. First, we need to find Celsius. So we do 5 divided by 9 times 2,500 minus 32, and that gives us 1,371.1 degrees Celsius. Then, once we figure that out, we put in the Kelvin formula, which is Celsius plus 273, which gives us a total of 1,644. One of the things that was difficult for me in the beginning of the semester was differentiating cation and anion, and I made this catchphrase to help me out. Remember that cation is positive because it has the letter T in it, and leaving anion to be the negative charge. Jonathan was having some problems with some sig figs, so I give him some rules. Zeros leading do not count. If a zero is sandwiched between non-zeros, it counts, and trailing zeros only count if it contains a decimal. Both agree that dimensional analysis is probably the most difficult part of this chapter, and converting from metric to metrics gets really confusing. So here's some example. 5 days is equal to 1 day over 24 hours. This equals to 1 hour over 60 minutes. 60 seconds over 1 minute, which leads us to 432,000 or 4.32 times 10 to the power 5. So this question asks us the density of sulfuric acid is 15.28 pounds per gallon. What is the density in gallons per milliliter? So first on our picket fence, we want to put 15.28 pounds per gallon. Then we put 453.6 grams over 1 pound to cancel out the pounds. After that, we put 1 gallon over 3.7854 liters. And then we put 1 liter over 10 to the power of 3 milliliters, leaving us with an answer of 1.831 gallons per milliliter. This is asking us how many liters of gasoline will be needed for a trip of kilometers per hour. We're given 27.5 miles per gallon. Then we convert 5,280 over 1 mile, cancel those out. 12 inches equals 1 foot, cancel those out. 0.0254 meters over 1 inch, cancel that. And 0.001 or 1 times 10 to the power 2 kilometers over 1 meter, which gives us 44.25696. And how many kilometers are in 27.5 miles? We do 489 kilometers divided by 44.25696, which gives us 11.05 gallons. Then we times that by 3.7854, which gives us 41.8 liters.
Hi, this is Jonathan Garcia. I'm in group 14. Sorry, but I'm a little sick, so my voice is a little raspy. So there's just some dimensional analysis practice. And I like using the picket fence method. And I chose this because I kind of struggle with the dimensional analysis. And these are problems from the book. So in the first one, it was kilometers to feet. So you would start with kilometers, and then go to meters, and then convert that meters to centimeters, and then to inches, and then to feet. And then I made sure to have the value that I needed to be on top at the end. And then I got 3,281 feet. And then the next problem was cubic inches to cubic meters. And whenever you do like cubic values, you want to make sure to cube all the conversion factors as well to get the correct answer in the outcome. So This answer I got was 1.6 times 10 to the negative fifth meters cubed. And then these ones I actually had trouble on remembering the prefixes and what they stand for. So this like weird U, it stands for micrometers, and then this is millimeters. And I chose not to do a picket fence for this one for some reason. I just felt more comfortable just doing it like this. And then I was able to convert these, and it actually equals 10 to the negative third micro, or millimeters, so we go ahead and change that there. Okay, so for the last problem, it was the microseconds to nanoseconds, and I did the picket fence method on this one, and it's 1 microsecond, and then you convert that to 1 second, so I just converted to like the base factor, and that equals 10 to the negative 6 microseconds, and then from the base factor I converted that to nanoseconds, which was 10 to the negative 9 seconds. And then that in the end, that equals 10 to the negative third nanoseconds.